Alright, so here we can just talk about, we just discuss about all the data types, all the 8 primitive data types. We were talking about primitive data types, and now again, primitive data types are not the objects. This is the only one thing in Java that is not an object. Now, automatic promotion. What is automatic promotion? Automatic promotion is when one data type is automatically converted into the other data type. It automatically gets converted into other data type. Right? Automatic promotion, as we have discussed, that basically we can divide the data types in Java broadly into two categories. We can divide them broadly into two categories. Right? So we have these categories, and the first category is yours primitive data type, the other is complex data type. We are having primitive data types, and next is your complex or reference data type. These are actually the objects. These are the objects. Right? Now, automatic promotion is basically when one data type automatically converts into another data type. Automatic promotion can only take place between primitive data type. One data type can promote into another data type in primitive only, and one data type can convert into other data type in reference only. Means automatic promotion can occur only between the same categories. Automatic promotion can occur only between the same categories. It cannot happen that primitive data type is promoted to reference data type. Right? So automatic promotion can occur only between same categories. What is the example of automatic promotion? For example, if I'm just taking here something as float f is equal to 22, right? Now here integer is being automatically converted into float. So this is automatic promotion. This is, if I just go for system dot out dot println and f, once I write this and once I run this, so it's 22.0. So in this case, an integer is automatically converted to float, right? Yeah. Integer is converted to float, right? Similarly, if we also see, we have also studied that character and integer are having relationship between each other, right? So if you can just take is int x is equal to, if I just go from a, right, and system dot out dot println x. So if you see here, right, and I just run this pipe, it is character is automatically promoted into integer here in this case, right? Character is automatic converted into integer. So a character is automatically converted into integer. And currently actually what we are discussing is, we are discussing automatic promotion in between primitive data types only. So in regard with size, what you should remember is the smaller data types can easily fit into larger data types. You can remember one thing, that small size data types can easily fit into large size data types. For example, integer is easily fitted into float, right? Integer will be converted to float. Float can easily be converted to double. Similarly, a character is converted to integer. Character is of smaller size and integer is of greater size. So character can be converted to integer character can be converted into integer. Then byte short can be converted into integer automatically. Byte short can be converted into integer. These are the examples of automatic conversion in between the primitive data types. There is also one more thing. In integer value, a value without a suffix, means in integer the suffix is generally L. So without any suffix, integer automatically tries to convert into an integer. Any integer literal. It may be 97. You may write it as byte s is equal to 97. So any integer literal without suffix will always try to convert into integer. This is also one very strong example of automatic conversion. I'll just give you an example for it. That if suppose you have a byte b is equal to 10 and byte c is equal to 2. Right? We have byte b is equal to 10 and we also have is byte c is equal to 2. And if we write byte d is equal to c into b, this is completely inside the range, but it gives you an error. It is 20 and it is in the range of a byte, but it gives you an error. And just see what is an error. Possible loss of precision. Required byte and found int. Means since these values are present without any suffix, by default value, while calculation, it is automatically trying to convert into integer. But on the left hand side, it is only byte. So this here in this case, it is automatically trying to convert into. So here example is now when we perform calculation, it automatically tries to convert into integer. So it is giving an error. Yes, we need to tell the system that this is byte, this is not integer. Actually this can be done through typecasting. That is our next topic. So now it's fine. This is fine. This is typecasting actually. Anyways, similarly any float value, any decimal value without f is treated as double. Right? Similarly any decimal value without any without f is treated as double. It is treated as double. Without f it is being treated as a double. Right? So this is what is known as automatic conversion. And automatic conversion can occur only between primitive data types. Means one data type of primitive data type will promote to another data type of primitive data type. Right? Okay. In some cases, for example, float cannot be converted into integer. Float cannot be automatically converted into integer, right? Or double cannot be automatically converted into integer. So if we want to convert one data type into another data type, right? And it is not done through automatic conversion, right? We want to do manually, right? Then we can use typecasting. Manually means we need to write explicitly converting one data type into another data type, right? Is typecasting. This is typecasting. Example, we can just see, if we can see an example. If suppose a integer value, right, character can be converted into integer because integer is big, but an integer cannot be converted into character because integer is 2 byte and character is 1 byte. We can do that through typecasting. Example, we can convert a character into integer. Integer into character. We can convert integer into So you can just see here int x equal to 10, and if I try cap a is equal to x, so this definitely gives me an error, possible loss of precision. So what can I do here is I can simply go for this is correct. So explicitly specifying the data type, this is known as typecasting. So in typecasting we need to specify the data type explicitly. So example, we need to specify the data type explicitly. This is correct. Now what we can do is we can just go for int. Suppose we are having float f is equal to 34.5, and I go for int x is equal to f 34.5 f. It is giving possible loss of precision. Float cannot be automatically converted into integer, but integer can be converted into float automatically. So we can use typecasting here. Now this is fine, and if you just system.out.println next, you just run it, it's 34. So here the float is automatically converted into integer. So we convert the float automatically, right? Oh sorry, means by typecasting. We do this by using typecasting. Right, so we are very clear that now even typecasting cannot occur between two different categories. Typecasting can also occur between one category only. Right? So typecasting, it can also occur between one primitive data type to another primitive data type. Similarly, one reference to another reference. Typecasting will also occur in reference data type. Once we'll study about them. So typecasting can occur between the same categories. Typecasting can occur between same categories. It can easily occur between the same categories. Right. Now what happens when primitive data type, can we convert primitive data type into reference data type? Yes, we can. We have certain technologies, we have certain methods to convert primitive data type into reference data type, right? This specific phenomena is known as boxing. We call this converting primitive data type. Currently you can just know the definition, and how to do it we'll definitely look at it. Primitive data type into reference data type is known as boxing. So converting primitive data type into reference data type is known as boxing. Similarly, the reverse is known as unboxing. Converting a reference data type into primitive data type, it is known as unboxing, and this is known as unboxing. We call it unboxing. Converting a reference data type back into the primitive data type is unboxing. Converting reference data type into primitive data type is unboxing. We'll soon see how to do boxing and unboxing. Okay. There is one more small definition that you should know currently, that what is actually, we have just seen boxing and unboxing. There is one small concept of wrapper classes. Now as I already told you that everything in Java is an object. So Java also provides classes for each and every, it provides class for each and every primitive data type. It provides, primitive data types are not classes, but if you want to use data types as objects, you have been provided these classes. Right? These classes are known as wrapper classes. Right? So what are wrapper classes? The respective classes of the primitive data type is known as wrapper class. Example, you have completely integer, this is a class. Integer, this is a class. Byte, this is a class. Short, this is a class. Like short is a class. So the respective classes of the primitive data types are known as wrapper classes. We'll discuss more about wrapper classes in very much detail. Right? We'll discuss all these things in very much detail. Right. But currently we just need to look at the definition.